video, I'll discuss truth tables and show the relationships for the if-then, the conditional, and the if and only if, the biconditional. First, I'll do an example with if-then. In this example, I'll use a statement P, make an A on the final, and Q, pass the course. So if I want to consider if P then Q, then that would be, in words, if you make an A on the final, then you pass the course. So that's the statement I'm really considering here. For my truth table, I'll have a column for P, a column for Q, with the normal values filled in. For P, it's true, true, false, false. For Q, true, false, true, false. And what I really want to get at is what the relationships for P, if P then Q are, that is the truth values down in the table here. So let's examine this statement over here. In the first row, we have that both P and Q are true. That is, you made an A on the final, and you passed the course. And to give this a little more context, let's say I told you this. If you make an A on the final, then you'll pass the course. Well, again, in this first situation, you made an A on the final, you passed the course. Did I lie to you? Is there a problem? No, this statement makes sense for everything we've seen. The if-then statement should be true there, and it is. Looking at the second row, P is true, he made an A on the final. Q is false, you did not pass the course. Would you have a beef with me? Would there be a problem with this statement if P is true and Q is false? Certainly. That's a false statement. The if-then breaks down if P is true and Q is false. Going on, if P is false and Q is true, that is, well, you didn't make an A on the final, but you passed the course. Is there a problem with this statement I made to you? Is there a problem with me saying if you make an A on the final, then you pass the course? Well, since you didn't make an A on the final, this doesn't really apply. There's not really a problem with this statement. We're going to consider the statement true. And this is important. Again, if P is false, that if-then statement is true here. And in fact, going to this last one, if you didn't make an A on the final and you didn't pass the course, well, you didn't make an A on the final, this doesn't really apply even. We're still going to say that this statement is considered to be true. That is, you wouldn't have a problem with me saying this to you. There's no problem with the statement, even if it doesn't really apply. So again, we see in this example that if P then Q, the value on a truth tables should look like, the values on a truth table should look like true, false, true, true. Put another way, we see that if P is false and Q is true, then the statement if P then Q is false, and in all of the other situations, if P then Q is true. Again, if P is true, Q is false, if P then Q is false. Otherwise, each of the statements is true. Very important to note about the if-then statement is that the order that these things come in matters. That is, if the first thing is true, regardless of what it is, call it a box, and the second thing is false, call it a circle, this order stays the same. It's not important that it's P or Q, because we can reverse those. It is important that if the first one is true and the second one is false, the if-then is false. Otherwise, it's true. Next, let's consider the biconditional. That is the if and only if statement. The if and only if statement looks like this. P if and only if Q, and it's called the biconditional because it's really the conditional in both directions. That is, this is exactly equivalent to if P then Q and if Q then P. Alright, we're going to go through showing this truth value table in a little while, but let me give this to you. What's going to end up being the case is that if P is true, Q is true, the biconditional is true. If P is true, Q is false, the biconditional is false. If P is false and Q is true, the biconditional is false. And in the last situation, if P is false and Q is false, the biconditional is true. This is equivalent to saying that if P and Q are the same, then P if and only if Q is true. Note again, if P and Q are both true, it's true, or if they're both false, it's true. That is, if they're the same, it's true. Otherwise, P if and only if Q is false. And that's the rule we'll use for the biconditional. Have fun with logic.